All right, so welcome to Rough Housing Relatives Online. Yeah, woohoo. We're going to be making a totally not Smash Bros. Clone with totally not better networking than totally not Smash Bros. Nintendo networking. So yeah, it's going to be fun. We're making a multiplayer game that can talk to other computers over the interwebs. Pretty exciting stuff. Hopefully you're familiar enough with Unity already that I can talk about functions and fixed updates and things, and the execution order, and you know what I'm talking about. But otherwise, I'm gonna just focus on the networking aspect of it. So the first thing, I have a presentation at the beginning, but people can be downloading Mirror and setting that up in the background and creating a new project while I'm going through the presentation. So I just want to make sure that everyone has that. There's also a package that I put on the Google Drive. I post a link there. Make sure you have that downloaded. That's going to be all the built-in scripts for the platform fighter that I've set up so that we can only do the networking part of it. So I just posted the Google Drive link, download the package, and then make sure you're also downloading the Mirror. If you have Unity open already, in the package manager, a Mirror will show up like this. I should be currently logged in. If you click on the cloud icon or my account, yeah. So I'm already logged into this Unity project. So because I'm logged in, under packages and my assets, Mirror shows up because I'm subscribed to it on the asset store. So you'd want to download it in here with the download button. So I just want to make sure that everyone understands this part. So I think they can be doing this while I'm going through the presentation. If anyone does not understand, please let me know right now. You can use the chat. No, I guess everyone understands perfectly. Cool. All right. So I'm going to go through the presentation then. Rough Housing Relatives. Beautiful logo by none other than Bailey Atwood. Thank you for that. Just went through this. So, well, okay. Let's go ahead and install the package for the platform fighter, because then I can just go ahead and explain how that works. So this is a brand new project, and all I did was drag and drop in the .unity package file. I got a single error that was complaining that the sample scene conflicted with the scene that I had. I just ignored it and deleted the sample scene. But otherwise, that's all I did for here. So I'm going to assume you have the package installed and you have the scene looking like this. It's called the online scene. And you can delete the sample scene that Unity gives you. So if you start playing the game here, you got WAS controls, and you can jump, and you can press a J to attack. You can go through the semi-solid platform. It's nice. All right. So the controls are this screen right here. There are attacks based on which way you're facing or the current movement key you're pressing. And then some of the movement mechanics are that if you hold down in the air, you fall faster. And if you hold down on a semi-solid platform, you fall through it. And if you hold down on the ground, you move slower. Now, there are some setup that you need to do in the project settings, which could not be put into the package. So the first thing you want to do is go to the input manager in the project settings. And for the horizontal and vertical axes, change the sensitivity to 1000. I think the default is 3. What this does is that those inputs in Unity are analog inputs. And when you're using keyboard inputs, it kind of interpolates between pressing A or D and then kind of a virtual joystick. The default speed is very slow. So just make it 1000, and now you should very quickly be pressing the left or right joystick as if you're pressing A or D. That's also why jumping is kind of slow, because there's a dead zone implemented to that. So this just means that you reach the dead zone pretty much instantaneously. Another setting you want to change is in the physics tab. You want to make the gravity 0, -40, 0. The default is -9.81, which is Earth gravity. But if you've been playing around with the scene, you'll notice it's really floaty, which is accurate from a physics standpoint, but not really good for game design. So we're going to crank up the gravity a lot. In tags and layers, you're going to create a tag called semi-solid, and then user layer 8 would be hitboxes. And after you've created those layers and tags, you want to go back to the physics tab and make sure and uncheck the checkbox for the hitbox layer so that doesn't collide with itself. So I'm just going to show it in Unity now. My input manager has the axis here, horizontal and vertical. The sensitivity is 3, so I'm going to make it 1,000. And now in my physics tab, make the gravity -40. And if I go down to the bottom, I'll see the layers here, the collision matrix. I don't have any of the hitbox layer yet, so I can go to tags and layers. Tags. Okay, the semi-solid tag's already there. Layers, I'm gonna add hitboxes. And then back to the physics tab. Now I have the hitboxes show up here. I'm gonna uncheck it. So the layer collision matrix is how Unity handles what layers collide with what other layers. So if I uncheck the box, that means that if something's on the hitbox layer, it won't collide with something else on the hitbox layer. So if two players on the hitbox layer, that means they won't collide with each other and they can go through each other. All right, and that should be all for the project settings. I'm just gonna go back to the scene and double check that our player beam, yeah, it's on the hitbox layer. So the other thing I want to talk about are the player rigid body settings, which I already have the bean selected. The rigid body is on the bean. There is no drag because the player movement script has its own custom friction and acceleration. So we don't want to use Unity's drag equations. Angular drag doesn't matter because we're not rotating. We're using Unity's default gravity, which is what the physics tab does with this gravity value here. That can be custom, but we're just doing that for simplicity. Make sure to turn interpolation should be on already. That means that physics are updated like every fixed time step. Interpolating just means that between each time step, each fixed time step, it's going to interpolate the frames between that. So even though you might have 200 FPS, the physics are only updating 30 times per second, for example. So we want to interpolate so that that can be smooth. The collision detection mode is continuous. I'm not going to bother explaining all these. You can read a lot about how all of these work, but basically discrete is very cheap computationally, but if you're going fast, you sometimes go through objects. Continuous is going to be more accurate, but a little bit more expensive. But when you're going fast, you don't go through things. That's true in most cases, but eventually you're going to mess with these and realize that you're going so fast that none of these matter and you got to implement your own collision anyway, but this works for now. In constraints, we have all of them except for the X and Y freeze position because we don't want physics to tell us how to rotate. And also we don't want to move in the Z direction, which is forward and back in the 3D dimension because it's a 2.5D game. So the only ones we care about are X and Y. And lastly, on the capsule collider, there is a phys map frictionless. And the reason for that is because Unity's default friction is like 0.3, and that's fine for like physics simulations. But for a game where you have custom movement on the ground and you've already got custom friction, you don't want Unity's friction to mess that up. So in materials, there is a frictionless material, which is a physics material, and the friction is just set to 0 and the combine is set to minimum. The default, unless you specify a physics material, everything just uses the default. So by using minimum friction combined, we make sure that everything we touch is going to always have 0 friction. This also means if you rub up against a wall, you're not going to stick to the wall because there's no friction on that. And some other notes are that semi-solid platforms are a tag on a game object. And they rely, if you looked into the code, they rely on the player being called local player, which I'll explain later, but this player prefab will become named local player as soon as you start the level. The weapon anchor, all these objects here that are parented to the beam, these are all, none of these have collisions, so they don't have a hitbox. It's just the mesh renderer. And weapon anchor is just an empty. So the attacks are done with ray casts and not really with a trigger. And then I already mentioned this, but the beam is on the hitboxes layer. All right, so that's all I really wanted to explain for the game itself. Any questions on that? I'm getting null reference exception on all the platforms. Interesting.
It's coming from line 55 of the semi-solid script, where it's seeing if the player object plus the offsets greater than the top of the platform. I'm wondering if it's because
oh, yeah. So that's probably because, I mean, it might happen at the beginning, but then it should stop. Does it happen like all the time or just at the beginning?
Oh, no, I think I know what it is. The player name's not being changed to local player for whatever reason.
Interesting.
Like when I go to play, it's still player.
Check your player script. On the start, it should be this. There should be this line in the start function. It says this.gameObject.name is equal to a local player. This is a bad coding practice because of exactly the reason, the problem Bailey is running into. But for the most part, it usually works. And especially for just a workshop where this is just like a basic rundown. I just wanted a simple thing that would work.
Yeah, it says this.gameObject.name equals local player in the start method.
Huh. And it's not being...
A quick and dirty fix you can do right now is probably just rename it yourself.
Okay, I can do that. It seems like it's an error that's just on my end too, so.
Yeah, that's weird that it's not calling start.
I'm actually having this too. I was looking around for it.
Huh. Interesting. What version of Unity are you guys using?
Mine is...
This one's...
I'm on 2020.2.
I'm 2020.2.6F1.
I'm using 2020.1.10 and I'm not having this issue. Could it be that your Unity version is too new?
That's weird.
That's what it seems like.
That's such a weird error, though.
It might have something to do with the fact that an awake or a start is being called before another one. And so Unity gets all mad at it. But does changing it to local player manually solve the issues?
Next up is the actual networking part, which is what you guys are here for. So we're using Mirror, which is a third-party open source API for networking in Unity. Unity used to have its own built-in networking code called Unit, but it's been depreciated. So Mirror is actually the successor to that, where they took Unit and they've just been updating it. So they have their own documentation. However, because it's based off of Unit, all of the old documentation still applies. And if you find old tutorials, they also still apply. So you'll find during Googling, a lot of what you get will still work. There's also another option called Photon, which is third party, I don't remember if it's open source, but it does things completely differently and has its own tutorials and own way of doing things. So that's the reason I chose Mirror, because all of this old documentation still works. It's a lot easier to find information that you're looking for on Stack Exchange. Yeah. So some terminology I'm going to be using: server or the host client, client, local player or local client, server authoritative, and client authoritative. A server is just an instance of the game or that controls clients. It can be another client, but it doesn't have to be. You can also just have a standalone server that doesn't run a client. That's where things get a little bit messy, because then you have to take into account whether or not you're a client, or whether or not you're a server, or whether or not you're both. A client is just any game instance that's connected to the server. So if you have the server, but then you can have people on their own computers. They're going to have clients that connect to the server. You can even have multiple clients on the same computer. And the local player or local client is, when you're writing code, it's the owner of the player object. So you can have two players on the screen, and only one of them is a local player, and it's the one that you're the owner of. So you can check if or whether or not you are the local player based on that. And that's just a built-in thing for networking. Server authoritative is whenever the server tells the client what to do based on the server's information. And that's always gonna be more secure, because hopefully no one's hacked your servers. Client authoritative, on the other hand, is gonna be where the client tells the server what to do based on the client's information. And that's less secure, because the client can hack their own client and just give the server garbage data, but the server accepts it anyway because it's client authoritative, and the server just does whatever the client says. If you're just making a fun game to mess around, this doesn't really matter, but it will start to matter for taking into account lag and what to do when lag happens. I also just want to preface that writing networking code is completely subjective. There's a lot of ways to do something. It involves, well, for one, programming. You got to know what the order execution of events. It becomes very important. And it's also just a design question, because something can be implemented in a whole lot of different ways, and it's situational to what you need. And ultimately, it's up to you to communicate with a designer, or if you're your own designer, to make up your mind on what exactly you want to accomplish with the networking. In the package that I've provided, I've used good programming practices, but I've also been thinking about networking since the beginning. So I was able to write functions so that it's really easy to network. And you'll see later on, when we get to that part, why that is. But always, if you find a better way to do something, you go do it that way. I'm not a computer science major. I'm a civil engineer. So all of my explanations here are coming from as a designer, not as a programmer. So even though my technical explanations might not be 100% accurate, they're what makes sense to me in my mind as someone who isn't familiar with computer science or the theory behind this kind of stuff. So anyway, with that out of the way, I'm going to go over the remote actions and the thought process of what it's like to think about networking and what are some things you want to consider. This is a handy dandy diagram on the Unity 3D manual for networking. It's kind of there's kind of a lot going on here, but really what matters here are that you have the client and you have the server, and they're two separate things. And the communication between them is done with commands. And so a client has their inputs and they give commands to the server. which go to the server's copy of the player. Then the server does its own calculations. And then whenever the server's ready to tell the client what happened, it uses client RPC calls. And then the client receives that information and updates their copy of the objects. So I've said copy, and what this means is that any client you have, or when you have a client, you have your Unity project and you make a build of it and it's a game. Every single script you have, unless you've specified otherwise, like for a server only build, every single script you have will run on every single client. So it's up to the networking code to determine whether or not you're the server or you're the client and whether or not to run that script or that line of code. And there are built-in Booleans that can handle that. But that's basically really what it comes down to, is juggling and thinking ahead about, do I need this function to be a command or client RPC? And I'll explain what those are in a couple slides. And actually, I want to draw my own diagram for this because it'll make more sense that way. So I got paint.net here. So let's say you have a game instance here. Oh my goodness. All right, here we go. This is me, this is the client. I want to do something like, I want to attack. So I could press the attack button on my keyboard. And then what that'll do is that'll call a function like that, and it'll be a command. All right. The commands are run on the server. So even though the commands are only run, or commands can only be called by the local client, but they're run on the server. So what this means is you have a ton of clients. This client cannot call a command on my thing. Everyone has their own copy of the game running the exact same scripts. And so every single player object is going to have its own commands. But if you try to run a command from someone else's player object, it won't let you do it. It only lets you do it from your own player object. So like there's gonna be 10 player objects in the scene, and they all have their own player movement script. And if you press W on your keyboard, they're all gonna try to walk forward or jump. But because you can only send commands from your own player object, only your player object will send its information to the server. And then there's also errors that happen if you try to do it the other way. Well, okay, so you have the command that goes to the server. The client says, hey, I want to do something. And the server's like, okay, I'll do it. After the server does whatever the client told it to do, it'll usually do a client RPC, which is going to all the other clients. And these will be client RPC. So client RPC is the server telling every client's copy of that player object what to do. So this will make more sense later, but the client RPC is indiscriminate in the sense that even though only this player object sent command, every single instance of this player object will receive the exact same client RPC. And it's up to the code to determine what to do with that information. And this is the main hurdle that I came across when working with networking, is understanding this loop of information where every single client has the exact same copy of the script or of the player. But whenever you send a command, it's only that one player object doing it. And then client RPC gives it to every copy of that. Does that make sense? So I think I have a next slide here that shows what the commands and client RPCs look like. So A command is when the client tells the server to do something, and whatever's inside of the command is run on the server's copy of that object. A client RPC is when the server tells a client to do something, and that piece of code is run on the client's copy of the game object. Then there's also a sync variable, and this is a tag that you can put on variables where whatever information's on the server will automatically be synced to the client at a fixed rate. So this is useful for things like health, or a score, or a timer. Well, maybe not a timer, but for health and scores. You can have the health change on the server, and then you don't need to use a client RPC to tell the player that their health changed, because it'll update with the sync var. Sync vars only work from server to clients. You can't have a client sync var to the server. That's just one of the caveats with that. Yeah. And then some other things are built-in components that Unity Mirror has, and well, Unity Unit also had network identity and network transform. These are going to be the main components that we put on game objects that need to be networked. So a network game object component should always be on the root game object. So if you look in the scene in the game, you have the player object, and then inside of that there's the capsule. Even though the capsule is doing the moving and the player is just an empty game object, all of the scripts are on the player game object, not on the capsule. So, well, for one, that's nice and neat, because then you know that every script's going to be on the root game object, and you don't have to go digging through a ton of scripts, a ton of objects to find what you're looking for. But this is also just how networking is supposed to work. A network identity will automatically network everything that's parented to that. So it needs to go on the root object. Then there's network transform, which does what it says. It'll periodically update the transforms of the object to everyone on the network. And you can change that interval, but it's really simple, and there's no lag compensation or client prediction or things like that. So a lot of times you'll just find that if you're lagging a lot, your position won't match exactly to what someone else's screen says, that's a design question. Like, that's up to you to figure out how you want to handle that kind of situation where two people are lagging and the player positions aren't accurate. You can do like client prediction to kind of use velocities and kind of guess where they're going to be and like maybe update that. Or some games do like rubber banding, where if your position doesn't match up exactly to what the server thinks it should be, you rubber band. There's a whole lot of ways to approach that. And then finally, there's network transform child, which is going to be required because network transform alone does not network all of the childs, because you only want to network a couple things. There's some things you don't need to network. So in this case, you need a network transform in order to have a network transform child. So for this game, we're going to be using network transform and then a network transform child for the bean. And then also later a network transform for the attack anchor, the weapon anchor. What else we got? We got network manager and HUD. This will be we're just going to use the default network manager and the default network manager HUD. They're fine for testing and just like getting something working. But eventually you're going to want to make your own custom ones, especially if you're going to be sending offline information to the server you're connecting to. So if you're going to be using usernames, or you have a player customization screen or character selection screen before you join the server, or you can have that stuff while you're already connected to the server. It's up to you. But the main thing here is that the network manager has do not destroy on load on it, which means that only one instance can ever exist. And so you should only place it in the offline scene. And whenever you connect to the online scene, it'll automatically transfer over. So this actually becomes handy because later down the line, when you have offline information or just information that you want to save between scene transitions, you can just stick that onto the game object that has the network manager, because that'll always be like static to your client in that sense. Yeah. What else? And that's it. That's basically, those are like the only things we need to have this networking working. Any questions on that? You can always Google this stuff. Google will be very helpful. The documentation for Mirror has some nice guides on how to use a lot of these things and examples. And that's how I learned most of it, just from like Googling Unity Mirror, RPC, and then you get this remote actions page. And that's where I got this picture from. But like there's this thing here called that gives you examples on how to use it. So you put the command tag over a function. All these things will happen inside on the server side, but it's the client that called this. And then like you have things like not is local player and things like that. And then you got the client RPC calls here. Oh yeah, I forgot to mention this. Very, very important. Remote actions, commands, whatever. Anything that the only things that can be sent over the network are basic built-in Unity variables. And there's a couple exceptions, but when you write a command or you write a client RPC, you can only send basic information over the network. So you're like writing code and you like want to do like, oh, you want to give it like the mesh and you want to give it the material, and you're just like doing all that. That won't work because you can't network that. That's a more complicated question to network those, because those are assets and those need to be downloaded. So when you're writing code for networking, you want to send as little information as possible, just the bare minimums. And for one, that's faster and less information to send over the network. And two, that's just how it works. You can't send like a material over the network with these commands and client RPCs. What you can do is you can write structs, which will come very in handy once you start getting more complicated networking things. So as long as the struct only has these things, it'll work. But yeah, this page is very important. I reference it a lot because I don't memorize these and I need to remember. All right, so without further ado, let's get into the network code, shall we? All right, so let's import Unity, let's import Mirror, because right now it's just the offline stuff. So I go to the package manager, got in packages, my assets. You should be logged in my account. Then this will show up. I'm gonna click import. And then you're gonna get a bunch of checkboxes. There's some that you don't need. So just gonna collect the content. All right, so now we got all these beautiful things. Minimize some of these. The only ones that you don't need are the examples, because that'll take extra long to import those. And you need everything else is okay to keep. Just uncheck examples. If you don't uncheck it, no, because it takes like 3 times as long to import. So you're gonna be like stuck importing if you keep it checked. If you can make your own blank project and then import it, and it's actually pretty cool to play around with these and like see the code examples. But for the purpose of this workshop, just keep it unchecked, because if not, you're gonna be waiting a while to import all of those. But yeah, that's all. Yeah, no, if it's already been imported, it won't mess anything up. The only thing is that you can't unimport it because it changes like some background processes for Unity. I'm gonna go say right now that when you're working with networking stuff, you're gonna be making a lot of builds for your project. You're gonna be making a lot of builds, so because that's the only way to test the networking aspect is with 2 clients at the same time. So you got to make a build for that. All right, that's imported. Cool, we got this mirror folder and we're all good to go. So let's just create a new scene. Well, actually, what do we want to do first? Yeah, let's just make a new scene. We're going to call this the offline scene. And all this default stuff is fine. Then we're going to make a new empty game object. Put it 0 if you feel like it. And now, since we imported unit or mirror, we can add a component, and we're going to look for the network manager. And we're also going to add to this the HUD, which is still there right there. And this game object will be the network manager. And so that's all we have to do for the network manager, for now anyway. We're never going to make another one of these anytime soon. Let's just look at the options here. You've got don't destroy and load, make sure that's checked. Auto start server build, that's good. Server tick rate, this is going to be how fast the server updates. We're just going to leave it at 30 for now. Offline scene and online scene. This is very important. You might be tempted to put the offline scene and the online scene as the exact same scene. Or like, you might be tempted to put the network manager in your online scene because that's going to be faster. But don't do that because you're going to run into issues and you're going to be like, why is this a problem? And it's because you put the network manager in the same scene as the online scene because we're not destroying on load. So now you're going to have 2 copies of the network manager, and that'll cause issues. So just from like the beginning, only have a dedicated offline scene and a dedicated online scene. And the online scene should not have a network manager. And now the KCP transport's okay. You can do some research on what the transports are, but the default is A-okay. Network address is going to be localhost. Max connections, 100 is kind of a lot. Just do like, it really doesn't matter, but I'm just going to put like 16. That doesn't matter. Authenticator doesn't matter. Player prefab, auto create player. So because this is the default game manager, or not game manager, network manager, we're going to let the network manager create our player for us. So auto create player is checked. And our player prefab will be this player prefab here, which is already there. We're going to take and drag it in there. We got an error. The player prefab must have a network identity. So let's add a network identity to our player. Double click the prefab to open it. So like I said in the presentation, all the networking things will be in the root object. So make sure that the root player object is selected. We're going to add a component. Network. And that should be good. So now we can go back to our scene here, go back to the network manager, and now we should be okay to drag in the player prefab. No, we're good. All right. So now we're done. We got network game. Awesome. Good job, guys. Let's go ahead and build this. Go to build settings, PC, whatever. Check development build because that'll give us the command box and it'll give us errors. Add the open scenes. Oh, actually, yeah. Okay, so the scenes in the build will be the offline scene and the online scene. So we can add the open scene to add the offline scene, but then we have to go back to the online scene and add that too. So now we have both the offline scene and the online scene. When you click build, it'll give you a place to save it. So I'm just going to save it where I put all my builds. And it's okay to overwrite. Like when you're making multiple builds, it's okay to overwrite the current folder that you've already selected.
Also, I noticed you can just drag scenes into the, list.
Oh, that's good to know. All right, so after I selected a folder, it's gonna build it. The first build takes a while because it's gotta cache things, or I don't know how building works, but every subsequent build's always gonna be faster. A little bit anyway. So this will give us an exe that we can run. Also, you want to make sure that probably should have mentioned this, but make sure that the offline scene is 0, because that's going to be the first scene that loads. You don't want to load your online scene first. You want to load the offline scene first. All right. So I got my build. I'm just going to double click the exe. If you get a Windows pop-up for the firewall, just allow access or cancel. It's up to you. Oh, right. It's going to be full screen. All right, so this is what it looks like. There's nothing here because it's the offline scene and we didn't put anything in the offline scene. We got these buttons on the top left, and these were from the network HUD. Got host, which is a server and a client. Got a client, which connects to localhost, or you can just server only. We're going to do host plus server and client. And this is the online scene. So it created, it changed the scene to the online scene, and it created the player prefab. However, which is actually going to be tough to notice here, there's actually 2 player objects stacked on top of each other right now because we did not delete the player object that was already in the online scene. But because they are both exactly the origin, I can't tell right now. But that's what's happening here. So we can fix that. I'm just going to stop the host and close this. So here on my online scene, there's the player prefab already. We don't need that anymore because it's being spawned by the network manager. And also in my project settings, I'm just going to make the player not full screen. And not allow the, how do I,
Hey, Alberto, some of us, it didn't switch the scene when we hosted.
if you exit full screen, you press Alt Enter, but it didn't switch the scene.
Mm-hmm.
Did you okay? So let's go back to the offline scene then and check your network manager. Did you set the offline scene and the online scene respectively in scene management on the network?
I did not. Am I supposed to?
Yes.
Okay. So offline, offline, online, online.
Did you include both of them in the build settings? Yes. Did you make sure that the offline scene was 0?
Yes.
All right. So next time you build, it should work that time. Well, actually, you don't need to build. You can test it in here. You can just press the play button while in the offline scene. If you press the play button in the online scene, nothing will happen because there's no network manager in there. So, yeah. Now if you press host plus server, it should give you the online scene. You might be tempted, huh?
Oh, where in the project settings is the full screen turning that off?
In the player tab, you got like the PC icon, and then there's a drop down for resolution and presentation.
Okay.
You change the full screen mode to windowed, and then I also checked the box for resizable window. Yeah, you might be tempted during testing that you get tired of having to switch to the offline scene to press play, and you might be tempted to put the network manager in here. But like I said before, you want the offline scene and the online scene to be separate scenes in here because otherwise you're going to cause issues. The GUI. Oh, did you add the network manager HUD to the network manager game object? It's a separate component that needs to be added on top of that. And then also the show GUI checkbox needs to be on there. Yep, going step by step to make sure we catch these issues.
This isn't really a big deal, but I'm getting those null reference exceptions now, but only in the build.
Man.
Yeah, like I can see it in the development console. It's not affecting the gameplay at all, but they are popping up. Yeah.
Man, that's so weird the way that happens. Do you know, like, are you able to like read what it says? Can you like copy paste that?
I can try. I'll do some digging on my end.
Are you using the 2020.2?
No, I'm in 2020.1.3.
Huh. Yeah, that's so weird that I really have no idea. Like, the code should not have any like unique things in here. But did you delete the player object in the online scene?
Yeah.
Did you, well, I'm assuming, yeah, I guess you set the player prefab in the network manager and gave it a network identity.
Everything's working for me now. It's just those fun exceptions. But it's fine. They're not impacting gameplay at the moment.
Well, yeah, but there's still issues. Okay, well, I guess we'll just keep going then. All right, so now we can, let's try this. I'm gonna build again. But this time, I'm going to have 2 instances, and I'm gonna try to connect to the server of the other one. And I'm going to use the Unity editor as one of the instances so I can see what's going on. So we got, I'm going to press play on the Unity editor here. And now this is the server plus client. And on this one, I'm going to connect to the client localhost. And localhost is just the computer. All right. So now we're getting some errors. Some solid, okay, perfect. Console. Huh. Interesting. I'm just gonna ignore those. All right, so now we should have 2 instances, and we can't see each other connected. That's normal because we haven't actually networked any of the movement. So now let's do that part. And we go to our player object, prefab, and we're gonna add some new components. This is going to be the network. And I'm gonna actually double click the prefab to see the hierarchy. I get the feeling those null reference exceptions will be fixed once we actually start messing with the code. Because right now we have not touched the code and it's still not networked, which I'm expecting will cause issues. But we'll see. Because since when you join a server, it'll instantiate a new player object, but the player object will have the exact same scripts on it. So if there's double references to things, that'll cause issues. So like when you're pressing input keys, both players will move at the same time. And I know for the semi-solids, oh, Unity just crashed. Cool. Well, for the semi-solids, since I hard-coded that player object name, I was expecting that to cause issues. But we're gonna fix that when we start networking this and like only change it to local player if it is a local player. But for now, every single player instance will be called local player. Now I just gotta restart Unity. Maybe restarting Unity will actually fix some things. Yeah, you add a network transform. And then you're also going to add a network transform child and make the child be the capsule or the beam. Okay, we're back to this. Scenes, comments, pretty fast. Player, network transform is already there. And then we're going to add network transform child. Because the network transform only network transforms the root object, but we have children in here that are moving. So we got to add network transform child. And the target is going to be the beam. And this is actually going to have client authority. Yeah. So this is like one of the things where it's server authoritative or client authoritative. We want movement to be client authoritative because that's going to be snappy and quick. Which means if you speed hack, it's going to work because the server's not checking if your moves are legal. That's going to be a more complicated problem to solve and how you accomplish fixing or accounting for that. But for now, it's fine just to have this be a client authoritative movement without any checking. The sync interval is going to be how often the updates get sent to the server. If it's 0.1, that's only 1/10 of a second. So it's going to look really stuttery. Our rigid body has interpolate. So it'll look smooth on our side, but it'll still look kind of choppy on other people's sides. So we can lower that down. And you can actually go pretty low with this. I'm just going to set it to like 0.05, which will be twice as fast as the default. But now that we added this network transform component, what should happen is that any clients that are connected will have their movement sent, will have their positions in transforms sent over the network. Okay, let's see if that worked. Oh, I did a mistake where I tried playing the server with the online scene selected, so I can go back to the offline scene and start it here. Hey, all right, so now we have 2 players and their movements are being sent over the network. But as you can see, it's very choppy. And also when you press the keyboard inputs, both players move. That's because the input script is not checking whether or not you're the local client. And it's just a blink. It's doing it for every single object on the scene. Or it's running for every object on the scene. But we can test something real quick. We can look at the hierarchy while the game is still working. And we'll see that there's 2 local players. Just gonna select one. On one of these, all these scripts have checkboxes. So on one of them, that's not you could uncheck player movement and attacks. And now when you're like move, now only one of them is moving. So what unchecking the scripts does is it stops the fixed update and update loops from running. Yeah, you might be getting that error because we still haven't done any checking on in this code. What fix the network GUI? Add the network manager HUD to the network manager object. All right, so now let's actually start trying to fix the problems that we've run into. So one of the main problems we've had is that the scripts are blind and they don't know whether or not they're on the client or the server, or if they are the client or if they aren't the client, the local client. So let's check the, let's just go to the player movement script. And right now it's a mono behavior. This will become a network behavior. So we're gonna add a new library here using, and now we get access to all of the networking goodies that Mirror has to offer. And one of the first ones we're gonna do is network behavior. And now that it's a network behavior, there's gonna be a lot of built-in things that'll help us. You don't have to make every single script a network behavior. And once you get more familiar with how this all works, you'll know when and when not to use a network behavior script. One of the caveats to using network behaviors on literally everything is that any script that's on, any network behavior script that's on a game object will get its own network identity. So that's just more things that the server needs to keep track of. And so if you can avoid using a network behavior, that's just going to be better performance and less things sent over the network. So ideally, I would not make player movement networked and just disable it. But for the sake of simplicity, I'm just going to make it network behavior, because the only thing in the start function is this .component.player, and then everything else is an update or fixed update. So if you uncheck the script, nothing else here will run. But because this is now a network behavior, we can just add in some lines here at the top of update. And it's going to be if not is local player. And if you're wondering where this Boolean comes from, it's just a default Boolean that comes with network behavior. And that's something that took me a while to realize. It's like, where is this Boolean coming from? It's just a built-in thing. And there's a lot of other ones too, like it's server or it's client. But the one we care about is local player. And from the presentation, local player is the client of the owner of the game object. So when we were joining the other server as our own client, and we were moving both characters at the same time, it's because both characters had their own player movement script, and there wasn't a check for this. But now there is. So now when we join the server and we're checking for this, both scripts are still going to be there, and they're still going to be running. But because we have this check now, it'll ignore everything for anything that's not the local player. So let me complete this if statement with return. So if we're not the local player, we exit the update loop. And actually, we're going to copy this, and we're also going to put it in the fixed update loop. So now these two loops will only ever run if we are the local player. And so there's also this Boolean for ground check, but this is part of the fixed update, so we don't have to put anything there. And that's everything in here. Update is every single frame. Fixed update is only every physics frame. And I'm using update to get keyboard inputs because those are called for every single frame. But because we have physics-based movement, it doesn't make sense. We shouldn't be updating our movement every single frame because that's expensive. So we do movement in physics update, but we do player movement, or we do player input in the update script. So let's say you have 250 FPS. you would expect that with that high frame rate, that as soon as you press a keyboard input or click the mouse button, it'll happen that frame, or it'll take that input on that frame. So that's why we use update for that. Yeah, Anthony brings a good point. Like you do camera movement will be an update because that's a camera moving is updating the screen. So you want that in update. Yeah. Yeah, Anthony summed that up really well. Yeah, all right. So now player movement is good. On start, this is fine, just because it's good that this reference is getting filled because it's just a private variable anyway. We could add this in here too, but it's not. It doesn't really matter. Now the next one we want to mess with is player and attacks. So actually, I think player was already open. Yeah. All right. So now do the same thing here using mirror. The player script has all the data of the player, like their health or their damage percent, and as well as handles respawning. So now that it's a network behavior, this part right here where we're setting the name, we can now change this so that it only happens if we are the local player. And we actually get a built-in function for that called onStart. Oops. There's one called onStart local player. Time to Google this because I don't remember what it was called. So just do mirror on. Okay, I don't remember what it's called. So instead of that, we're just gonna put it in here. If is not is local player. There is a function for it, but I can't remember what it's called. And Google didn't give it to me, but that's okay. This will work just fine still. That's gonna bother me because I thought I would find it through here. Oh, yeah, see, it is on start local player. Network behavior. Huh. Oh, do I have to do public? Right. There we go. Yeah, there it is. So it's okay, yeah. That's why. Start local player. So it's a built, so the network behavior has its own built-in function here in the base, because we're extending this, we can extend this class, but you call the base function, and now here, this is where we put this stuff. And now we actually don't need this anymore. So we can actually right-click this and go see the source. Did you add the using mirror to the top? Because that's what will give you access to the network behavior. Jack. Network behavior with a U. Yeah. its network behavior with a U. All right, so I'm just going to reiterate, we can create our own onStart function that's for the local player, but it's an override, so you have to do public override. Actually, it doesn't be public, it can be private. Actually, I don't know what that does. Oops. And now we just moved the here. So now what happened with this now is that it'll only rename the game object if we're the local player. So now we shouldn't have the issue where it's complaining that there's two local players or that it's not renaming, because now this is what will happen. So if you did rename the prefab, you can rename it again because now it should be set here. So that anything that's not the local player will have a different name. In our fixed update, we're going to do the same thing here. Actually, yeah, if is not local player, and yeah, that's it for now. One more thing on the attack script. The attack script will also be networked. Function. And the fix update as well. All right, so we've modified player movement, player, and attacks to be network behaviors using mirror. And in the update and fixed update functions, we put if it's not local player return. And then we did a special case for player where we added the override on start local player, and we just moved the stuff from on start to be in here instead. And those are all the only modifications we've made so far. I'm gonna make a new build just to test that out. Is anyone behind? Because some people are having trouble with the network behavior thing. I can catch you guys up while this is building. So now I started the server, and this got named to local player. And if I join as a client, so now this time we have a second player clone in here, but it's not named local player because it's not the local player. And we wrote that here. So this function never ran on this copy of the game because it's not the local player. But on this copy of the game, it did run. And actually now that we're moving, only one character is moving around. And it's updating the position here too. Yeah. And actually if we attack, you can see stuff happening, and now they're going to start flying off into infinity. That's because our attack script is not taking into account networking yet, and so on my copy of the game, I'm attacking them, but that's not being transferred by the network. So on their copy of the game, nothing's happened yet. So I think I can do it like this. So I attack like this. See that nothing happened on this copy of the game. And actually at this point, the health is desynced and the lives are desynced because that's not being communicated. You're not getting a second player. Huh. Interesting. That could be a bunch of issues.
Would it help if I said that I haven't gotten a second player, like at all? Like when we implemented it the first time?
Oh, did you set the player prefab?
Yeah.
Well, I guess, yeah,
I'm wondering, I think it might have something to do with who the host is. All I've been doing is opening up the .exe and doing the server or host and client.
On the exe.
Yeah.
Did you delete the player object in the
Oh,
online
no,
scene?
I did not.
It might be conflicting with the one that's already there. Okay. Well, now we can. Now that we have. Did you start the game in the game window? I had one instance of the game in the game window, and I had one instance in the as an exe. Now we can actually start networking the attacking. And so, if you've noticed, in the prefab, the extendo arm is just parented to the weapon anchor. And so whenever you attack, the only thing that's happening is that the scale and the rotation of the weapon anchor is changing. So it's like changing to like 5. And when that scale changes, it's like showing the extendo arm. So because I'm only using a transform for this, I can actually just use a network transform. Oh, right, network transform child. And this time the targets can be the weapon anchor. And that should network the visual aspect. Yeah, okay, so your network characters keep drifting off to the side. We'll get to that. That's because the physics are still happening on your screen for that character. And so we want to turn off physics for anything that's not your character. And then that way, you're the only character that has physics, and we can do that right now. But all I changed to the prefab is adding a second network transform child and making that the weapon anchor. Back to the code. In our player, we had on start local player. There's also override on start. Oops. Actually, we can just use on start for this. That's not what I wanted. So in the start function, we can do if it is not. We're going to take our rigid body, which is just body, and then we're going to set the constraints. Rigid body constraints dot resolve. So what this will do is that if the script starts and we're not the local player, then all of the constraints on the physics on the rigid body will be enabled. So the only object in the scene that will have its constraints enabled or disabled will be your local player. And that means that any movement that happens for the other players will be entirely from the network transform and not because your client is doing physics on their player object. And we added that. Now we can actually network the attacking, and it's right now it's just a ray cast, yeah, whatever you want to call it. So in our attack script, there's this function called do attack, and it takes the an origin point, a direction, and then a last thing called the owner of the attack. We're not actually going to use the owner, but it's just there for future reference. So do attack is already set up as a function, and conveniently, it's already got everything we need to make this into a command. So right now, this is only ever executing on your local client. So on my screen, I'm attacking a player, but because that code is only running on my computer, nothing is getting transmitted over the client for that attack. We can change that because this is already a network behavior, and all we have to do is make this a command by adding the command tab or the command tag. And so these two are already default networkable parameters, which is what which are on this page here. Game objects are a special case because in order for them to be networked, they need to have a network identity on them. In this case, the game object owner is this .game object, which is the game object of the attacks component, which will be the player component, with the player game object, and the player game object will have a network identity. So it's okay to have this in here. And you might think that I was like, oh, I'm sending the game object, so I can just like, I don't need any of this. I can just use the, like I can do like owner.transform.whatever. That won't work because what you're sending over the network is just a reference to this game object. So like an ID basically. So if I do owner.transform, it'll be the server's copy of that transform. Or it'll be the client's recipient copy of that transform. It doesn't have any data associated with like the actual or like what was sent over. It's just a reference to it. This is useful later on if you want to extend this project to have like teams or like usernames so that you know who attacked who. So the attack just has the owner with it on it. And also just to demonstrate that it works because it has a network identity. But really what matters here is that we're telling the server what origin point and what direction we're using. So this is client authoritative attacking because it's based on what, or the position is based on what the client says. However, commands are run on the server. So my client says, hey, I want to attack at this position in this direction, and this is me. The server is going to say, okay, let's show your weapon, let's do all this. But show weapon is now being run on the server's copy of the game. So now what happens on your screen is you're going to press the attack button, but you won't see the attack happen. You're like, wow, what happened? So that's because this piece of code now is running on the server. So the server should tell you that to show your weapon so that way you know that you actually sent the attack. So in this case, we're going to convert show weapon into a client RPC. So we can go to the definition here, which is just below command or below do attack. And we're going to change this to client RPC. Oh yeah, one more thing I forgot to do is for any commands, you want the prefix to be command, CMD. And then for any client RPC, we want the prefix to be RPC. And that's just good practice. Oh, I should not have done that. Actually, I can right click it, rename. And that conveniently renames all of these. Nice. And now I'll do the same thing for this one. This is also just good practice because now you know that this function is a networking function and it should be called in a special circumstance. And the same thing for this one. So now now the order of events that happens here is I press the attack key. My client tells the server I want to do an attack. This code is run on the server, so I can put a comment here. This is run on the server. And now I need to show the weapon so that the server acknowledges that the attack happened, and that the client acknowledges that the server knew that the attack happened. here. This is run on the client. Fun fact is that even though I'm only doing the command on my client and it's running on the server, the RPC gets run on every instance of this script. So if we have 5 player objects, on my screen, I'm gonna press attack. It gets sent to the server. This code gets run. RPC show weapon gets run on the server's copy of my player object. However, it does not get sent only to me. It gets sent to every copy of my player object. So right now what would happen is I did the attack, the server registered it, it's doing the RPC. This piece of code will run on everyone's computer. So depending on the use case, you might have to do if is not local player. And then you do something different in that case. Looks like maybe one of the examples is for respawning, or well, actually that's not good. Well, maybe, but in this particular case, we do want this to run at every client because every client should be able to see that you did the attack. So we don't actually need this here. This is run on the client for every copy of this object. Right, did that explanation make sense? So now these are being run on the client, and now we're going to do coroutines, which doesn't matter how that works, but it's fine. What is this one? Spam mode. Hide puppet. Okay, yeah, that's fine. So now that should be everything to network the attack script because the raycast is already set up. One thing to note here is that since this is running on the server, and whenever this piece of code runs to check whether or not we're hitting something, it's using the server's copy of the game. So if people are lagging, the server's copy of their positions will be a little bit behind what everyone else's screen shows. But that's just how this is going to work because we're not doing lag compensation. We're not doing client prediction. So on your screen, you might detect that you hit someone, but the server's going to disagree because the server's positions is going to be behind what you see. So for now, that's fine. But just something to keep in mind is that you might want to, depending on your use case, do these calculations, this raycast calculation on the client. So we would have like a do local attack function that does this raycast, and then the take damage stuff will be commands, right? But right now what's happening is these take damage commands are run on the server because we're inside the command still. So we can now go to this definition, which is in the player object or the player script. And this is a public script. It can be, or a public function. It can be called from everywhere. But we don't want to accidentally damage our local copy of someone else's player. We want the server to handle damage and their health values. So we're going to add to here if is, or actually we can do if is server this time. Or if it's not the server. If it's not the server, we're just going to return. So this only runs on the server. It runs on the server. And now we can go back to attack. And there's also a knockback. And knockbacks can be a different case. Oh, see you, Mitchell. because knockback deals with player movement. And like we did before, player movement is done client side. But right now this function is running on the server. So if we try to affect movement on the server, nothing will happen because the client doesn't get that update, because the network transform is only one way. It's only happening from client to server. So we want to take knockback into a RPC. So if we go to attacks here, this take knockback, we're going to rename it to RPC. And then we're going to add RPC to it. So now what's happening is we do the attack. This is run on the server. Take damage is still run on the server. But when we go to the RPC take knockback, that's being run on the client now. But once again, RPCs happen on every single copy of that client or every single copy of that object. So we need to make sure that this is only happening on the local player. So if it's not the local player, we exit. This only runs on the local. This is also why sliding was happening, because we weren't checking for this. So when you attack someone, you're giving them knockback, and your copy of their player was doing knockback. But because your copy of their player was not doing player movement, then there was nothing on your copy of the game that added friction to them. And the only movement that was happening was from the network transform. But since you were adding a force and their player is frictionless, they're just going to keep sliding. But now that we're checking for this, knockback will only ever happen on your local client, which is where movement is happening. And so now if you hit someone, it's going to the server, the damage is happening on the server, but the knockback is happening on their copy, on their local player, not on yours. And you're using the network transform to see what happened to them. And now this is run on the server, but because take damage is only run on the server, there's nothing to communicate to your local player that you're taking damage. So I'm not actually, that was a lot of information. But hopefully my explanation made a little bit of sense. Is anyone like totally lost, or did we get these client RPCs in here? I think we're good for another build probably at this point. So I'm gonna make a new build. Yeah. I can explain that. So the order of events that's happening here is I'm a local player. I tell the server I want to do an attack, which is what this is doing here. This is run on the server. So the server is going to do the raycast. If the server raycast hits another player, the server will take damage. This function here is only happening on the server because this command is only happening on the server. So in the player here, this is only happening on the server. But we're just putting this here as a gut check to make sure that it never gets run on another client. But right now, damage percent is not being networked. It'll just always stay 0 because it's only ever being changed on the server. So in order to make that transmitted to the client, we can change this variable type to a sync var and give it that tag. So now that this is a sync var, any change to this variable on the server will be transmitted to the client. And there is a lag associated with this. In this case, it's fine. But like later down the line, if you try to do calculations on damage percent and it's not accurate, probably because of lag, then you might want to have an RPC to like force update it. Like you'll have an RPC take damage with just the new damage value. No, but for now, it's fine to leave it like this. So now we've networked the attack. We've networked the visual aspect of the attack, which is the show weapon. We've networked the take damage, and we've networked the take knockback. We haven't networked reset yet, but we don't have to because, well, actually, I'm just gonna add this in here. Reset, it has to do with the player movement because we're changing the velocity and the position of the player. So because this is handling with position and we have the network transform, we only care about this if we are ourselves, if we are the local client. So if it's not the local client, local player. And in this case, this is only run on the local client. In this case, it's client authoritative still. So it's up to the client to determine whether or not to reset themselves. The good practice would be to make resetting server authoritative. Just because then you have this server. And in the part 2 of the workshop, we'll make this server authoritative because we're going to do game loop of network game manager, which will handle respawning. But for now, it's fine to leave this as server authoritative and let this the client, or for now, it's okay to leave it as client authoritative and let the client determine whether or not they need a reset. So now we've networked this part and this part. All this was networked already. So I believe we have everything networked already. So I'm going to make a build to test our things out. How are you guys feeling? This is like super confusing.
I've kept up pretty well, but I've just noticed that I've got a problem with networked movement. I'm getting the null reference exceptions and the semi-solid again, but only when there are 2 players.
Okay. Okay, let's start the host. Move this guy out of the way. And I'm gonna add the client. Awesome. Yeah, this errors you're getting.
Hold on 1 second.
So
yeah.
Good job. Let's take on these. So let me try it. Attacking seems to be working. Let's try. Seems to be working actually. We can add more comments actually. I probably should have done that before. But let's try to fix the null reference exception with the semi-solid. So what I've been doing so far is making the editor the host, but I can do it the other way around. And I can make the exe the host. And this way I can see what's going on in the editor in the hierarchy with these errors. Okay, so these errors weren't happening. Oh, actually. Okay, they go away. Okay, so they stop happening. So this is because in our semi-solid code, we're doing stuff in fixed update. So it's normal for this error to happen because it's not defined. it's only going to be defined once it's created. And when we join as a client, stuff's loading in the scene. It's going to load the scene first. And then after it loads the scene, it'll put in your player object. When it first loads the scene, it has the other player in there that's not named local player. So you're going to have a couple physics frames, there were 6 errors here. So it was able to do 6 physics updates before it spawned your player, and then it renamed itself to a player and it went away. So the fix to this will be to just put an else statement here and then just return it. Actually, if the player object equals null, actually I'm going to put the return statement in here. So if the player object is null, we're going to attempt to assign player. Jack's leaving. See it, Jack? Client only has a gray circle around the middle. I'm not sure what that is. Yeah, there's a couple ways to fix this, but the way I'm going to just put it is I'm going to attempt to assign a local player, and then we're just going to return. If it is not null, that means it's been assigned, so it won't do this if statement, and it'll instead go over here. So that this return statement in here should fix that error. But as we saw, the error isn't particularly dangerous. It's just a side effect of how this very, very bad code that you should never do is written. Oh, yeah. So I just changed the code here, and it's supposed to recompile. So this is going to crash the game instance. Yeah, so because Mirror uses the player prefab, and that has the scripts for it, as soon as you make a change to it, the prefab won't match what Mirror is using. So you're going to get a ton of errors. So you always got to restart your client to make these errors not happen. And just for the sake of demonstration, let's say I want to put in on this command here, let's add a new thing here called material mat. So what I'm going to show here is what happens if you try to send something that you can't network over the network. No, you shouldn't be writing this. This is just me demonstrating it. I mean, you can if you want to. Okay, so we already got the error in here. Material can't be deserialized because it has no default constructor. That's fancy talk for this can't be networked. I think the one, sometimes you might be writing a custom struct and you'll have something like this in the struct, but it won't give you this error because it can't like do recursion like that. But if you ever see something that says Weaver issues, 9 times out of 10, Weaver issues mean that you're trying to network something that can't be networked. My host can't hit my client. Is that supposed to happen? You should be able to, because, well, I tested it on my end and it was working. But the host even though the command is running on the server, not the client, the host is a special case because the host is both the server and the client. So, I mean, that should still work. So, oh, does anything happen on hit? Yeah. Well, the feedback should be that the player got nudged because they took some knockback. You can do a test by clicking on the, okay, people are not saying nudges. Let me just, I gotta rebuild this now because I made some changes. But the nudge, so you have the command do attack, p.take damage and p.rpc take knockback. We turn the knockback into an RPC. In the player script, this is now an RPC, client RPC. And then we also did, if it's not the local player, return. Make sure you put the not in front of it. And then for the take damage, we made it if it's not the server. Another way you can check it is when you have the hierarchy shown, you can select the player object in the hierarchy and see the values of the player. So I can select it in here, local player, player script. It actually tells me it's a sync variable next to damage percent. I'm just going to join the client. If I press J, so now on the host, the damage updated. The client can nudge the host, but the host doesn't nudge the client. Oh yeah, I meant to add some debug lines. When you're in developer mode, the only debug lines that pop up are errors. So you're gonna make these into errors. So we can do debug.log error. And inside here, we can put client, big giant quotation marks. You took, and then on this one, server object took damage. And we can actually use, yep, all right, that should be good. So if the client can nudge the host, then, but the host cannot nudge the client, then maybe this wasn't, maybe you forgot to put client RPC on it. Because the host is also a client, if you forgot to put this in here, it'll still nudge the host because it's running on the host. But if you nudge the client, it won't do it because you're not transmitting that data back to the client. I mean, at this point, everything I've done here is the entirety of part 1 of the workshop. So the rest of the time will just be answering questions and fixing people's bugs. Client can actually, did you make it RPC take knockback? And then, interesting. Did you add if it's not the local player return? Can you put a debug message in the command and do like debug server? And then we can use owner this time. Owner. Joseph, do you want to share your screen?
Yeah, just give me a second. I'm gonna test this out.
Aaron, did you get yours working?
Not yet. I'm about to try it again now.
Okay. Yeah, putting in these debug messages is really like how you go about debugging this. And I do put the server tag and the client tag to like know where it's coming from. But yeah, it's going to take some trial and error. Like it's easy for me to say, oh, well, it works for me, so it should work for you. But like, you might have missed like one tiny thing, and then that messes everything up.
So I'm getting that last message that we set up where it says this player wants to attack.
Okay. So it is receiving the command. So at one, do you get the log that says hit something?
I am not.
Are you running this host on the editor?
I did.
So that means the raycast is failing, and you're not actually hitting something. Did you create the hitboxes layer?
Maybe I misnamed it.
It's case sensitive. So the B is lowercase.
That would be it. It's hitboxes, not hitbox.
Hey, there we go.
Typos.
Yeah, this is why I don't like working with layers, because things like that happen. And
Yeah.
there's no way you're ever going to realize it.
Oh, it needs to be named hitboxes?
Yeah.
With an ES at the end.
Maybe that fixes a lot of people's issues.
Probably.
Okay. That might well do it. So okay, yeah, that exactly. Okay.
Capital H, hitboxes.
I might just do it.
I tried mine out again, and it's still not working.
Make sure. I remember when I was setting the player to be in the hitboxes layer, I did like the one that was in the scene, which occurred to me just now that wouldn't do anything. So make sure the prefab has
It's the
layer.
prefab bean, right?
There shouldn't be a player in the scene.
Yeah.
Right. It was at the very beginning when we were going through stuff.
Oh, okay.
That was when I changed the layer.
Oh, the prefab also needs the layer.
Yeah.
You should not have a player object in the scene.
Correct.
Because that's created by the network manager. So you should just delete if it's in there.
It is not. I was just saying at the beginning when we were changing it, there was one in the scene, and
yeah,
that's the one I changed, and I didn't have the sense to do it in the prefab too. So
okay.
When setting the layer, do we want all child objects in player to be of that layer or not?
It doesn't matter, but because they don't have hitboxes, but no, they really don't need to be.
All right.
Aaron, do you want to share your screen?
Uh,
Oh, there's
I can't share my screen.
Hold on. Multiple participants can share, and oh, can I not? There we go. Okay. This might let you.
Stop sharing my screen.
All right. Give that a go.
All right. I can see your screen.
Oh, can you see my screen?
Yes.
Yep.
Didn't realize I was muted on. Okay. So like, oh wait, oops, sorry. No, didn't realize.
Yeah, it's going to get really annoying to switch back to the offline scene every time. And you might be tempted to stick a network manager in the online scene to speed it up, but that's just going to cause more issues. So it's just in your best interest not to do that.
So, this copy, and then nothing happens when I switch to the client.
Okay, I'm looking at your debug messages in the console, and I noticed that it was hitting something, so the raycast is working. But the knockback wasn't working. So can you go back to your code? Oh, you have different colors than me. Huh. Client RPC.take knockback. If it's not the local player return, client you took knockback. Oh, wait. Well, you put debug.log instead of debug.log error, so it wouldn't show. But that doesn't fix the problem because you still should have seen. Oh, is damage? Did you put damage as a sync variable, or the damage percent?
Where?
At the very top. Yeah, that's it. So you're taking damage, but it's your updated damage value is never being transmitted to the client. So your knockback is calculated based on your current damage percent, and since you're never transmitting that to the client, it'll always be 0. So you're not quote unquote taking damage.
All right. So what do I need to change?
So you add the tag above damage percent with the brackets. It's called sync var, SYNC. Yeah, there it is. So what sync var does, that variable will now be synced from the server to the client. It doesn't work from the client to the server.
So it should work now?
It should work now because now whenever you damage something, it'll update your damage percent, and when the knockback is calculated, it'll have the proper damage percent number. That fixed Udayan's issue as well.
I'm gonna stop sharing. Thank you.
Yeah.
And my issue was fixed too.
Awesome.
So.
Everyone's issues are getting fixed. That's good to hear.
Is there anyone else that's having problems?
Everyone good? Everyone like their networked Smash Bros. Clone? Rough housing relatives?
So question, the attack, I noticed it would like push in and then like it would push out and then back in, like it has an animation on
Yeah.
the networked ones,
Yeah.
but it doesn't on the not networked. Why?
Yeah, because network transform is interpolating. So yeah, that's the easy answer.
Okay, it basically creates an animation.
Yeah, because like your transform is like your scale is changing instantaneously,
Mm-hmm.
but because the transform is interpolated between 0.0 every 0.05 seconds or 0.1 seconds, it's interpolating between those time steps.
Mm-hmm.
So if you wanted to happen instantaneously, then instead of making it a network transform, you would change it to be RPC commands and RPCs. So where it says show weapon, you would, oh, actually, wait, we did make it an RPC. Oh, okay, that was my bad then. We actually, since we did make it an RPC, we actually don't need the network transform child for it.